Okay, we're going to look at this problem real quick because a lot of people have been asking me about this. Now, Sabrina here throws one of Spainhour's mugs straight up into the air at a velocity of 22 meters per second. Again, single teardrop because I don't want my mugs to break. How long does it take to hit the ground, and how high did it go? All numbers in this problem are fairly ridiculous. Now I'm going to start off by drawing a picture here, and this is going to, some of this problem shouldn't probably be as accurate or as messed up as it is, but let's say the mug here in this problem starts from the ground level. Okay, so she's going to apparently be like heaving it up into the air. Sorry, Sabrina, there you go. There you go. It's prettier in real life. All right. Anyway, so the mug is going to go up at 22 meters per second. I'm going to set up this problem by saying up is going to be my positive. And now let's set up what we have here. Velocity initial, velocity final, acceleration, time, and displacement. Now, velocity initial, that's pretty easy. That's like the one number that's given to you in this problem, 22 meters per second. Okay. Velocity final, I'm not sure. Acceleration, pretty darn sure that's negative 9.81. Okay. Time, also not sure. And displacement, I'm not sure about that either. Well, there's some ways to look at this problem with something we call symmetry of motion. Okay. Acceleration is a constant 9.81 meters per second squared, meaning that your velocity is going to decrease by 9.81 meters per second every second. So of course in 2 seconds that's going to double, which tells us, by the way, that it should stop in a little under 2 seconds. But the thing is that it's going to take a certain amount of time, like we said, just over 2 seconds, for that mug to reach its peak, or to basically stop moving. It'll take the exact same amount of time, as well as the exact same amount of displacement, to get all the way back to the ground. So when the mug is traveling back down, it's a terrible third mug, the other two weren't fantastic either, but when it's going down, it will have had the same displacement and the same amount of time for acceleration to work, which means that it should have the exact same speed, just the opposite direction, so negative 22 meters per second as a velocity. Meaning that if I wanted to right away figure out how long it's going to take to hit the ground, velocity final can be negative 22 meters per second. And then all I have to do is, of course, plug in for time. Velocity final, velocity initial, plus acceleration times time. Of course, I have to be very careful here about putting these things in the right spot. I'm going to solve for time here real quick. So nothing cancels. So I'm going to do my algebra. Velocity final minus velocity initial, and divided by acceleration is equal to time. And that's going to be equal to velocity final, which is my negative 22, which came from the number. That's where that negative comes from. And then minus, which comes from the algebra right here, a positive 22 meters per second, all over acceleration, which is negative 9.81 meters per second squared. Meaning that should be a negative 44 meters per second, negative 9.81 meters per second squared. If you check the units, that'll definitely cancel it to seconds. Let's see what the calculator tells us as far as the rest. And my calculator tells me that the answer should be 4.49 seconds. Something real quick, whenever you're punching into your calculator to save you some time and effort, negatives can be a little bit tricky in the calculator if you don't put them in the right spot or if you put them in the wrong way. So anytime I look at this and I see my negatives canceled, when I punch it in my calculator, I don't throw negatives in there at all because I know for a fact they're going to cancel. So 44 divided by 9.81 just takes a little bit of time out of what you're doing. You don't have to do that, but there's our answer, 4.49 seconds. We're going to look at this exact same problem again from a slightly different angle now. But before I do that, I just check the internet real quick, and it's actually symmetry with 2 M's. I knew that was wrong on the spelling. Anyway, symmetry of motion. Now let's look at this from another perspective. You could also say that during that entire elapsed time, the displacement is in fact 0. This is another way of answering the same question. Now I can take these 3 terms and also solve for time. In order to do that, I have to use this equation right here. Again, a lot of people find it scary, but if you do things the right way, you'll be fine. In this particular case, you'll notice that displacement cancels. leaving us with a t and a t squared. Because I only have a t and a t squared, I actually do not need to use quadratic formula. There'll be a video for quadratic formula here coming next. Let's do this. In this particular case, let's plug in the numbers right away. Okay, velocity initial is 22 meters per second, delta t plus 1/2 times negative 9.81 meters per second squared, delta t squared. And that's equal to 0. You might remember seeing these from in your math class. If not, that's fine. There's an easy way to answer this. Okay? Because of the t squared, we know for a fact that there is in fact 2 answers to t. Now where exactly they're at, we'll find out in just a moment. Okay? What we'll need to do here is you'll notice that there's a t in both terms. So mathematically what we can do is we can pull that out. T times 22 meters per second. I'll simplify this while we're doing it. Negative 4.905 meters per second times delta t, end parentheses. Now, as I said a moment ago, there's going to be 2 answers. One is pretty easy. This is if this t is in fact 0, then that whole term would drop out and would make this 0. So my first answer to delta t is 0 seconds. Okay? The second answer to that is what is inside this term, or what t right here would make this all equal to 0. So I'm going to take this term right over here and set it equal to 0. 22 meters per second minus 4.905 meters per second squared, delta t equal to 0. I'm going to subtract the 22 over, then divide that underneath. So t will equal to negative 22 meters per second divided by negative 4.905 meters per second squared. And what we'll get in this case is the exact same as we got last time, which is 4.49 seconds. You might say, why did we get 2 answers at this particular time? Well, the reason why we got 2 answers is what math is telling us right here is the 2 times specifically, that the displacement is 0. Now it makes sense that the very first time the displacement is 0 is at 0, because that's once right here at this spot. The next time, of course, that we want is when it comes all the way back around, which is the 4.49 seconds. So in that particular case, that's our answer. The last half of this problem, how high does it go, is a fairly basic problem in which you don't look at the entire time, but you just look at half of it. Now you can in fact solve this problem a third way, and that is to just solve to the top, setting velocity initial at 22 again, solving velocity final in this case at 0, acceleration at negative 9.81 meters per second squared, meters per second on this, time not sure, and displacement not sure. Because I have 3, I can find time. That will be 2.245 seconds when you solve for that, once you figure that out. And due to symmetry of motion, you can in fact just multiply that by 2, which will give you your 4.49 seconds again. So there's about 3 different ways to solve this problem, and it's helpful to know all of them.